In lecture 18, we will discuss the unilateral Laplace transform and the differentiation and integration property of the unilateral Laplace transform. And we will also discuss one example question. And we already discussed bilateral Laplace transform. Bilateral Laplace transform is defined as integral minus infinity to infinity uh, x of t e raised to minus st dt. So this is a basic equation for bilateral Laplace transform. Okay, so we are considering signals which is having both positive and negative side. Okay, this is a t, so this is the positive side and this is the negative side. But in one-sided or unilateral Laplace transform, unilateral or one-sided Laplace transform, which is represented one-sided xi of s or x1 of s of a signal x of t is defined as, you can see it's from 0 minus. Okay, or we can simply say it's from 0 onwards. We are not considering from minus infinity to something, because in bilateral we are integrating from minus infinity to infinity, but in unilateral Laplace transform we are considering from 0 onwards, or very specifically 0 minus, because most of the systems are causal in nature, so we are considering only causal signals. That's a meaning for signals x of t is equal to 0 for t less than 0. So we will consider only signals which is in this particular form. So we can say we don't want to specify ROC in each case. In bilateral Laplace transform, we need to specify ROC in all the question. Okay, it's very compulsory thing. We need to write the ROC. But in the case of unilateral Laplace transform, normally we will not write the ROC, because in most of the case ROC is a causal signal, so we will be in this particular form. Okay, real part of s is greater than sigma max, means towards the right. That's understood. So this is a unilateral. So most of the case the equation and the calculation will be very easy. So now we will discuss the properties of unilateral Laplace transform. In unilateral Laplace transform, all the properties of bilateral and unilateral Laplace transform are almost equal, but integration property and differentiation property are different in the case of unilateral Laplace transform. So we will discuss these properties in this particular lecture. So if we take the differentiation property in time domain, in bilateral Laplace transform it's up to s into x of s, that's much. But in this particular case you can see that you need to write one more condition, minus x of 0. Okay, this x of 0 is actually indicating the initial condition. Okay, so when you do the problems with initial condition, you need to prefer unilateral Laplace transform. So in bilateral Laplace transform, the equation is only up to this much. Okay, only the term s into x of s. Now there is an extra term that is x of 0. And one more thing, this is Laplace transform, and x of 0 is actually x of t at t is equal to 0 minus. Okay, ideally it's 0 minus, in most of the cases we will write 0 itself, but x of s means is a Laplace transform, so both are different cases. So now we will take one generalized case, or if it is x square, okay, d square by dt square. So at that time you will write s square into one-sided Laplace transform into s into x of 0 minus x dash of 0, means this x dash of 0 is actually d by dt of x of t at t is equal to 0 minus. Okay, or 0. That's the meaning of x dash of 0. Similarly, if you generalize this particular equation, dn and dtn, so we will start from s raised to n, s raised to n minus 1. So here it is x of 0, but here it will be x dash of, similarly up to x dash of n minus 1. So this term will be like this, d by dt, next it will be d square by dt square, d cube by dt cube, etc. We will take x of t. Okay, and this is only term x of s. Okay, this is about unilateral Laplace transform differentiation property. Now we will discuss the integration property of this unilateral Laplace transform. So integration property, again integration property in it's simply 1 by s in the case of bilateral Laplace transform in one-sider or unilateral Laplace transform, it will be same if you start from 0 onwards. If the integration is starting from 0 to t, you can simply write 1 by s into one-sided Laplace transform. But if you are starting in the integration from minus infinity to t, so we need to write an extra term. So this is the same term which we explained here. Okay, there will be an extra term. Okay, that is actually indicating 1 by s into, we need to write the value from minus infinity to 0, okay, or 0 minus. So that case we need to consider separately. Okay, and this will be an extra term. This is the integration property. Now we will do one problem related to this. Normally in exam point of view, they can ask to solve the differential equation, or we need to find y of t, solve the, here it is a second order differential equation, and they will give initial condition. Make sure that when there is an initial conditions are given, you always choose unilateral Laplace transform. It's very important. Otherwise you can, if it is simply a differential equation, you can do the problem with bilateral. But when there is an initial condition, you need to prefer unilateral transform. Then only we can apply the initial condition values. Okay. Now we'll see how we can solve this particular problem, and assume that this y of 0 is also equivalent to y of 0 minus. Okay, it's almost same. So we can do this particular problem. So we need to take the Laplace transform or unilateral Laplace transform of this particular equation. Y double dash means d square by dt square. So you will write s square into y of s plus y into y of s plus s into, because it's d by dt, 6 into y of s, and here it is given x of s, and okay, so this is x of s, and this is a simple way when you use bilateral Laplace transform. But here this equation is not sufficient, because if we take unilateral Laplace transform, we will not get this, because each term we need to write a separate term. So I will write like this. First we will take y dash of t. Okay, y dash of t means d by dt of y of t. Okay, so here it is written as a bilateral form. Okay, but its initial conditions given, so we need to prefer unilateral Laplace transform. So if you take the unilateral Laplace transform of unilateral Laplace transform, if you take the equation becomes s into one-sided transform minus y of 0 minus. Okay, so if you write like this, you will get s into y of s minus, and the initial condition y of 0, okay, it becomes 2. Okay, this is first equation. Now we will write y double dash of t, which is actually d square by dt square into y of t, and if you write the unilateral Laplace transform, it becomes s square into y1 of s, or one-sided transform, into s into y of 0 minus minus y dash of 0. Okay, if you substitute the values, it becomes s square into y dash of s minus 2 into s, because y of 0 is 2, minus y dash of 0. Okay, it's 1. So we are getting like this. And if you take x of t, it is given e raised to minus t into u of t. So if you take the Laplace transform, unilateral Laplace transform, it becomes 1 by s plus 1. So we got all the terms. Now we need to substitute in this particular equation. Okay, to substitute in this particular equation, it becomes, we'll take the next page. It becomes s square into y1 of s minus 2s minus 1. Okay, this is one term, plus 5 into s into y of s minus 2 plus 6 into unilateral Laplace transform y is equal to 1 by s plus 2. So now we can group different terms. So if you group the terms, you will get s square plus 5s plus 6 into y1 of unilateral Laplace transform, which is equal to 1 by s plus 1 plus 2s plus 11. So here it is 11. Now if you simplify the right side, it becomes, if you take the LCM, it becomes 2s square plus 13s plus 12 divided by s plus 1. If you take the LCM here, now we can write y of s is equal to 2s square plus 13s plus 12 divided by, you can factorize this term also. So if you bring to the right side, it becomes s plus 1 into s plus 2 into s plus 3. Okay. And if you perform the partial fraction, so now we need to perform the partial fraction. If you perform the partial fraction, I will directly write the result here. We need to perform the partial fraction. So you will get, after partial fraction, I think you are comfortable with partial fraction, you will get 1 by 2 s plus 1 plus 6 into 1 by s plus 2 minus 9 by 2 1 by s plus 3. So we will get 3 terms, and now we can take the inverse Laplace transform. Okay, so if you take the inverse of this particular equation, it becomes 1 by 2 into e raised to minus t, maybe u of t, okay, plus 6 into e raised to minus 2t into u of t, minus 9 by 2 into e raised to minus 3t into u of t. Okay. So this is the equation. We are getting y of t. Thank you.